Okay, now let's see the code demo for building semantic role labeling. Semantic role labeling, as we have already discussed, provides a rich information to the text to identify each of the words and their semantic roles, so that the disambiguation process becomes very easier when we are working with an NLP application. So here I have used a package, and semantic role labeling, as we know that again this can be looked at as a kind of problem, as a classification problem, similar to POS tagging and NER. So POS and NER actually kind of task where every word has some kind of associated tag, right? So similarly, semantic role labeling can be looked at in this classification paradigm. So when we are trying to implement this SRL, semantic role labeling, through some kind of classification model, here I have taken CRF, that conditional random field, as our classification model. So to start with, now again we have to understand how the data set looks like. I am going back to the same parsed data as we have just shown in one of the code demos, where the parsed data has some column of information, where each of the column represents some kind of linguistic information. So the first is a token, the second is the token number, the first is a token number, second is a token, third is a lemma, fourth is a POS, and fifth is a language specific POS tags, if any, and sixth is the morphological feature, and seventh and eighth represents the labels and attachment of that particular label in the dependency thing. Now, this particular column, I actually combine these two features together, and if any enhanced information that is required, that will be actually kept in this particular column. And you could see in the kernel U format itself, in the last column, we are actually having a data with annotated with prop bank information. This prop bank gives you the kind of relation it holds, and what kind of arguments can occur with that one. Let's say there is an information here, ARG1 and ARG2 for the words like Google and engine respectively, and it's been connected to the verb. So that ARG1 represents more or like in this construction, of course Google is a really nice search engine. In this sentence, it's not an agent, but it is an equative kind of construction. So Google is one argument, and the head of a nice search engine is engine. So engine is the head of that whole chunk. So engine is being connected as an argument 2. So now the data what we have is argument 1 and argument 2, that is being identified along with what to be attached. Let's say this is the data set. Now how to implement it using the CRF. So let's start with implementing it through sklearn CRF suite. Again, let's install that one. Once we install the Python CRF suite, then we can download the data. Now I have used the data from universal prepositions data set. They have a number of tree banks where each of the sentence are being marked for semantic role labeled information. So this is similar to semantic dependencies, where dependencies in a kernel U format stops in 10 columns, whereas in universal preposition it will go beyond the 10 column. The last column represents the semantic role label. Now since we understand the data set or the data format, let's see how this can be implemented. So for implementing this one, because this data is in the kernel U format, so we have to import the kernel U to read the columns and to understand which column to be trained for when we are building a semantic role label. So again we are importing the specie. So now since this is a parsed data, now let's load the kernel data and create all the sentences in one place and temporarily hold the current sentence tokens in another list. Now the first thing is, now we have to again remove some of the things from this whole data, because we don't need all the information from the columns that we have seen in kernel U data. So now we are taking only the informations that are required, especially the kernel U valid line, that is 13th column, that extracts the semantic role labeled information. Now what else we need is the other features like word, pure stack and semantic role labeled that are being taken. As of course this is in the 13th position, but in the in the 12th list that are given in the data. Now once this is done, now we can easily train the data from the input that we are getting from here. Once the training is training information is being ready, let's start about what kind of feature that can be used, because it's a classification now. Are we using only the root pure stack and the semantic role labeled information, or any other features that can be used from the word that is being given here? So the features like current word, part of speech, and also the lower version of the word, whether the word is in the uppercase or not, whether the particular word is a title cased or is it a digit or anything else, all these informations are being extracted from the data, and we are going from again the similar kind of CRF training. When the word is not the first word, now add the feature from the previous word in this kind of function, and if the word again is not the last word, again add the features from the last word. So once this is all done, then we are converting the sentence into list of feature dictionaries. Once this feature dictionaries are done, now we have to extract the labels, that is here semantic role labels for a sentence. So we have extracting each of the word with their semantic role labeling, and we also extracting the words that have the tokens from the sentence. So we are sentence is converted into token, sentence with labels, sentence with feature. All these functions are being initialized. So now all these informations are important for training the data. Now for training the CRF model, as we have already seen in pure stacking and NER training stage, again we are using the similar kind of technique where we are again starting with CRF suite, and we are preparing the training and the testing data. Once this data is done, then we will start training the model. So some kind of regularization, coefficient regularization is being also done here. So once this is done, now we can evaluate it. For evaluating, again this data has a train and test set. We are actually iterating through each of the trained test data, and let's see how it can be evaluated. Before that, we also would like to know what kind of tags are being used in this data set. So let's print all the tags, that unique tags that are present in the training data. So the unique tags are here, like argument NPRR, argument location, distal, something of this kind is given here. So since this data is kind of coming from propositional dependencies, or sorry, universal propositional. So to know about these tags, we can still go there and get the guideline to get an idea on how each tag is different and what kind of semantic information it carries. And let's come to the evaluation part. Of course, evaluation, let's prepare the test data and start testing it. We will calculate the FN score, and again of course we can calculate precision recall, the whole metrics from the data. So now you could see the output for each of the tag metrics. So each of the tags precision recall and FN score is being also kind of calculated here, and since this is a very less data and less iterations are being again attempted, of course the results may not look like very promising, but we can still add more data and more iteration to make sure that the training is better. So the overall accuracy and weighted average is given here. For the given this data, the weighted average for this precision is 73, and 82 is recall, and 76 is an FN score. And yeah, this is how semantic role labeling can be implemented. Thank you.